Section 1.3. In Section 1.3, we will be looking at how a statistical study is done. In designing a statistical study, here I just want you to get an overview of how to design a statistical study. The first and most important thing to do would be to identify what it is you're interested in. What is the variable of interest, and what is the population that you're going to be drawing the study from. Then you need to come up with a plan on how you're going to collect the data. If you use a sample, you need to be sure that your sample is representative of your population. Then go out and collect your data. Then you need to describe that data using descriptive statistical techniques that we're going to be studying in Chapter 2. You then interpret your data, making sure that you can use that data. What kind of inferences are you going to be making about a population? You always go back at the end and look at your data to see if you can find any possible errors. Okay, now, there's different types of studies that are done. An observational study, the researcher just watches and records what's happening. Examples of that might be a researcher who observes and recorded the mouthing behavior on non-food objects of children up to 3 years old. They did not put things in the children's mouth. They just sat back and watched what objects the children put in. Another very famous observational study was Jane Goodall when she studied the gorillas. She observed and recorded the characteristics of that population that she was interested in. Another type of statistical study is an experiment. And in this case, the researcher is applying some sort of treatment to the population and observing what happens. So suppose you're interested in the risk of heart disease and cinnamon. So this researcher took a bunch of diabetics, gave cinnamon extract to some, and then another control group took none. Then afterwards she looked at the reduction in their risk of heart disease, while the control group experienced no change. That is an experiment because she has applied some kind of treatment to her study. Next is simulation. Simulation is often done with computers, and you are looking at what might happen. Things that are done with a simulation are often, if you are building an airplane, you do not put $1 million into an airplane and then see if it flies or not. You'll do a lot of simulations and try to reproduce the conditions before you actually put the airplane in the sky. Automobile manufacturers use simulations with dummies to study the effects of crashes on humans. Right? They do not actually put humans behind cars and crash them and see what happens. A survey. In a survey, it's usually done by interview, mail, or telephone, and you're asked a lot of questions, and they are investigating one or more characteristics of a population. Suppose a survey is conducted by a physician to determine whether the primary reason for their career choice was financial stability. She designed a survey and then asked her patients questions and recorded their responses. So let's decide which method of data collection, which type of statistical study was done. If you were studying the effects of changing flight patterns on the number of airplane accidents, do you think you actually put a bunch of airplanes up there in the air and then count how many crashes you have? Probably not. So that would be done with a simulation. Study of the effect of eating oatmeal on lowering blood pressure. Probably a group were given oatmeal every morning, and another group was not given oatmeal. And so the group that was given the treatment must have eaten oatmeal, and the group that was the control group could not have been given any oatmeal at all. And then they decided whether there was a lowering of blood pressure. This is clearly, and a treatment was applied, so it is an experiment. A study of how fourth grade students solve a puzzle. Probably the researcher just sat back and watched the students solve the puzzle, so it would be an observational study. study of the U.S. residents' approval ratings of the U.S. president, most likely done with a survey. They were asked the question and their response was recorded. All right, so the key elements of an experimental design: you need to be able to control it, you need to be able to randomize your data selection, and it needs to be replicated. So for control, you need to control for effects of other than the ones being measured. For example, if you are running a study on whether oatmeal lowers cholesterol, then you need to make sure that your control group or your placebo group is not eating oatmeal cookies or some other form of oatmeal or some other food that might also be lowering their cholesterol. So you need to control for effects other than the ones that are actually being measured. Confounding variables are variables that the experimenter cannot tell whether they're making the difference or something else, or the variable in question is making the difference. Suppose a coffee shop owner remodels her shop, and at the same time down the road a mall is being built. She finishes her remodel, she opens up her shop, and all of a sudden she has a lot more traffic in her store. But can she tell that whether the traffic increase is due to her remodel, or is it because there's more traffic on the street because of the new mall down the street? The new mall down the street is the confounding variable. The placebo effect. Often people who are told that there is a magical pill get better. That's sometimes known as the Dumbo effect, right? Dumbo couldn't really fly, but he thought the feather made him fly, so he got better. He could fly. So some subjects often react favorably to a placebo, even though they were really given no medical treatment. That's why the controlled group is often given some kind of sugar pill. In blinding, you don't tell the subject, here, you're being given a sugar pill, and the other subject is told, you're being given the new drug. These people are blinded, so they do not know whether they have received the treatment or the placebo. In a double blind, neither the subject nor the experimenter knows if the subject is receiving a treatment or placebo. Somebody down on a file is kept on who's got the medication and who's been given the sugar pill, but the experimenter does not know who's getting what. It is important to randomize. You need to randomly assign subjects to different treatment groups. That is often, in most statistical studies, require randomization. You can do a completely randomized design, so subjects are assigned to different treatment groups through a random selection. You have a big population. Think of it as your population. You give a number to everyone in your population, put them all into a bag, shake it up, close your eyes, and reach in and grab 20 numbers. A randomized block design means we might go ahead and divide subjects with similar characteristics, such as gender, into blocks, and then within each block randomly assign subjects to treatment groups. So for example, we have all of our subjects, right? There's our population. Then we blocked them in by age and then randomly assigned some from this group into the control group, some into the treatment group, randomly assigned from this group into control, into treatment, and randomly picked from this group to go into the control or into the treatment. In matched pairs design, sometimes subjects need to be paired up. So you might be paired up with diabetics, might be paired up with similar A1C levels, or you might have people paired up because they drive the same type of car. Replication is very important, that your experiment is able to be repeated using large groups of subjects. To test a vaccine against the flu, 10,000 people are given the vaccine and another 10,000 people are given the placebo. Because of this large sample size, the effectiveness of the vaccine would most likely be observed. We would not be able to do this same with doing 10 people being given the vaccine and only 10 people being given the placebo. Your sample size would not be large enough. So a company wants to test the effectiveness of a new gum to help people quit smoking. So let's identify a potential problem with the following. The company identifies 1,000 adults who are heavy smokers. The subjects then are divided into blocks according to gender, and after 2 months, the female group has a significant number who have quit smoking. One of the problems is the groups are not similar. The new gum may have a greater effect on women than in men, or vice versa. So maybe we should take the subjects divided into blocks according to gender, but then within each block they must be randomly assigned to be in the treatment group or the control group. A simple random sample means you have your entire population, you number them, think of them, you throw all those numbers into a bag, you shake it up, you close your eyes, you reach into your bag of numbers over here, and you just pull out your sample. That's a simple random sample. No grouping techniques at all or blocking techniques are used. Often a random number generator is used. You have them on calculators, and they have tables and back of books to do a to use a random number generator. I'm not going to look at that. So the number table in the back, because nowadays you can do it on a calculator. But if you you had 731 students and you wanted to form a sample of 8, well, you could assign the numbers 1 to 31, then either use a table of random numbers or your calculator that will randomly draw 8 numbers between 1 and 731. Now we're going to look at some different blocking techniques. A stratified sample means we first divide our population up into groups, and then we select a random sample from every group. So for example, we divide the county up into 3 groups: low income, middle income, high income, and then randomly select some households from the low income group. So we randomly select some from the middle income group and some from the high income group. The key here is after you've grouped, you select some from every group. Now a cluster sample, you begin the same way. You divide the population into groups. Then you randomly select groups and choose all from the selected groups. Often done when you're doing surveys that you have to drive to them. So suppose I divide the county up into zones. I randomly select several zones, and then every household in that zone is going to be in my sample. Systematic sample. We choose a starting value at random, and then we choose every kth member of the population. So somehow or another you must order your population, pick a random starting point using either a random number generator, or if it's a small enough number, just put the numbers into a bag, shake it up, pull out a number for your starting point, and then you choose every 10th member of that population or every 100th person. For example, suppose you order a household up from house 1 to house n, then you randomly pick a starting point and then choose every 100th household after that starting point. So for example, let's decide which sampling technique was used. You divide the student population into majors and randomly select some from every major. That's stratified. You assign each student a number, generate random numbers, and then you question each student whose number is randomly selected. There were no blocking techniques done. That is just a simple random sample. All right, so that's the end of section 1.3. You should have a good overview of how a statistical study is designed, how we go about collecting data, and then we talked a little bit about designing the experiment, and definitely some different sampling techniques from simple random samples down to more specialized blocking techniques. You are now done with section 1.3, and we can go to my math lab and do the homework set called Homework 1.3.